given that the velocity of a particle is v of t equals t squared minus 2t minus 8, find the displacement and the distance traveled during the time interval from t equals 0 to 6. All right, again, we've got two parts here. We need the displacement and we need the total distance traveled. The displacement is the easy part. We need to integrate over the given integral from 0 to 6 of the velocity function, v of t dt. So that's going to be the integral from 0 to 6 of t squared minus 2t minus 8 dt. This is a polynomial function, so it's continuous everywhere, which means we can use the fundamental theorem of calculus here. The indefinite integral is going to be t cubed over 3 minus t squared minus 8t. We've got to evaluate that at 0 and 6. So first we evaluate it at 6. That gives us 6 cubed over 3 minus 6 squared minus 8 times 6. And then minus, evaluating that at 0, all of those terms are 0. So that's a lot simpler than it could have been. So then we evaluate each term. 6 cubed is 216. If we divide that by 3, that gives us 72. And then minus 36, and then minus 48. 72 minus 36 is 36, and 36 minus 48 is negative 12. And because this is distance, and we aren't told if it's measured in meters or feet or anything like that, so I guess we can't put a unit. So it's just going to be negative 12, which means 12 units in the negative direction. Now, for the second part, for the total distance traveled, that is much more complicated. We need to integrate the speed function, which is the absolute value of velocity. So our integrand becomes the absolute value of t squared minus 2t minus 8 dt. And we need to figure out where in our interval that is positive and negative. So if we look at that function, t squared minus 2t minus 8, we can factor that as t minus 4 times t plus 2, because we need a product of negative 8 and a sum of negative 2. And we need to know when that's 0 to find the critical numbers. Well, that's going to be 0 at 4, which is in our interval, and negative 2, which isn't. So we need to be looking at the endpoints of our interval, which are 0 and 6, and then also at 4 for our sign chart. Now the factors we said were t minus 4 and t plus 2. T minus 4 is going to be negative when t is less than 4 and positive otherwise. And t plus 2 is going to be positive in each of those intervals. So our velocity function is going to be negative on the first interval and positive on the second interval. So what we need to do is we need to split this up into those two intervals. So we've got from 0 to 4. And in that case, we need to integrate the opposite of this function, t squared minus 2t minus 8 dt. And then we need to integrate from 4 to 6 the function itself, t squared minus 2t minus 8 dt. Now, in the first example I just did this sort of integral like it was. I distributed the negative to each of those terms, and we did what we needed to do. But there's another way to do this that I want to do in this problem, just to show you. If we're integrating the opposite of something, we can just integrate that thing, but switch the limits of integration, if it's a definite integral. This is the same as the integral from 4 to 0 of t squared minus 2t minus 8 dt. And then, of course, the other one is the same because that is unaffected by any of that. And the benefit of this is that both of the integrands are the same. And so once we find the antiderivative, we need to evaluate it at 0, and then subtract what we get when we evaluate it at 4, and then add what we get when we evaluate it at 6, and then subtract again what we get when we evaluate it at 4. So let's just go through and do all that in one go. We know that the antiderivative is t cubed over 3 minus t squared minus 8t. We've already done that. So let's just go and plug in the limits of integration here. If we plug in 0, that's 0 cubed over 3 minus 0 squared minus 8 times 0, which, spoiler alert, is equal to 0. That is nice. And then minus whatever we get when we plug in 4. So it's going to be 4 cubed over 3 minus 4 squared minus 8 times 4. And then plus whatever we get when we plug in 6. That's going to be 6 cubed over 3 minus 6 squared minus 8 times 6. And then minus that other bit again. Same thing when we plug in 4. Okay, we know this first part is 0. We also know what this is because we've already evaluated this up here. That part is negative 12. So that's going to make life easier for us because that's just going to be minus 12. And then whenever we evaluate one of these, it's going to be the same as what we get over there. So we might as well just evaluate that once. Let's do it kind of up here. 4 cubed is 64, so that's going to be 64 thirds. Minus 4 squared is 16, minus 8 times 4 is 32. Negative 16 minus 32 is negative 48, so this is going to be 64 thirds minus 48. And I suppose we can get a common denominator there. That's going to be 64 thirds minus, what is 48 times 3? 144 thirds. 64 minus 144 is negative 80. So it's going to be negative 80 thirds, but it's being subtracted. So this actually is going to end up being plus 80 thirds. And this other one, again, is going to be minus negative 80 thirds, but that's going to be plus 80 thirds. So what do we have? 80 thirds plus 80 thirds is 160 thirds. And then minus 12, that's 36 thirds. 160 minus 36 is 124 thirds. And that is a perfectly good answer, but if we want to have an idea of what that is in scale, if we divide 124 by 3, that gives us, 41 1/3. So that is another way of writing that. So there we go. The displacement in the end, they are only 12 meters or feet or whatever it is from where they started. I say they, it's a particle, but it's only 12 units in the negative direction from where it started, but over that time period it traveled further than that. It traveled 41 1/3 meters or feet or whatever.